All right, so let's talk about a variety of different graphs, or sometimes called data displays. We've talked about pictographs and circle graphs. We've also talked about dot plots and bar graphs. So you can see this is a web. So you can see here's pictographs, circle graphs, bar graphs, histograms. You could have double or single bar graphs. And then under plots, there's stem and leaf plots, dot plots, and scatter plots. And under line graphs, there's single line graphs and double line graphs. So the reason they're categorized like this is it might help you understand more the differences and similarities between them. And I want you to think about types of data when you look at these as well. A fun activity is to make a data displays foldable. On this data displays foldable, it has pictographs, bar graphs, circle graphs, stem and leaf plots, histograms, and dot plots. And you can draw an example of each one on the outside, and in the inside you can write advantages and disadvantages of each of the data displays, as well as what type of data they use. So let's talk about stem and leaf plots. Here's an example of a stem and leaf plot. Stem and leaf plots still need to have titles. On the left-hand side, where this 12, 13, 14, and 15 are, those are our stems, and then on the right, those are our leaves. And so each one of these is a data point. So 1 to 7 is a data point, 1 to 8 is a data point, there's another 1 to 8, and then there's a 1 to 9. And there's always a key with a stem and leaf plot, and you can see the key says 12/7 means 127 centimeters. So that's how you read a stem and leaf plot. Stem and leaf plots are used as a quick way of seeing how many pieces of data fall in various ranges. The reader can quickly tell the range, which is the max minus the min. It's the first measure of spread, how spread out your data is, and the mode being the most common occurring data point in the set. Stem and leaf plots have a title, stem and leaves, and a key. Histograms. So a histogram kind of looks like a bar graph. You can see that there's bars on it. You can also see that there's a title and your axis labels. So histograms are used to show the frequency of data. They're very similar to bar graphs, but use the intervals on an x-axis. The bars do touch. The reason the bars touch is now we have numerical data as opposed to in a bar graph where we have categorical data. So, and a good way to remember that is in a bar graph, you could rearrange the order of the bars and it wouldn't matter. For example, in an M&M activity, it doesn't matter if we graph how many yellow M&Ms we have compared to how many red M&Ms we have first or second. However, on a histogram, this information is numerical, so there's an order to it. Histograms still have a title, and they definitely have their axes labeled. A line graph. A line graph is also numerical data, and this time it's important that you see that we connect these dots, meaning this is continuous data, so it's data over time. So temperature for 1 week, you can see that the temperature ranged from in the 70s all the way up into the 90s. You could also have a double line graph. This is the amount of rainfall, and these are in 2 different years. So that's a nice way to compare those. A line graph is used to illustrate change over time. Line graphs need to have a title, labeled X and Y axes, and equal intervals. And the data is displayed by points connected into lines. A double line graph is similar. Again, it's a comparative tool. So what's a scatter plot? A scatter plot is when you have 2 numerical variables and you're looking for a correlation between them, or you're trying to discover if there is any correlation between them. So this is their grade versus the time they study. You would hope the longer they study, the higher their grade is. You might have heard of a line of best fit. This would have a positive association where it goes up from left to right. So as your study time increases, so does your grade increase. So sometimes we use this to look at correlations. The closer the sets are related, the closer the points come to forming that line of best fit. We could have a negative correlation, which would go down from left to right, and we could have no correlation at all, where the dots are just scattered.